So this is the lesson video for section 8.1. Alright, so we're starting chapter 8. So in chapter 7 we learned about ionic bonds, and in ionic bonds atoms will transfer electrons to other atoms to where they both become ions. You get a positive and a negative, and then that attracts together to make an ionic bond. So everyone wins because one loses its extra ones to become stable, one gains a few more to become stable, and then they're all like a noble gas and they bond together. Well, in this chapter, we're going to move on to covalent bonds. So sometimes two atoms may bump into each other and they both need another electron. So in that case, no one wants to give one up. So what they're stuck doing in that case is they're stuck sharing the electrons. Now, when they share, the electrons that are being shared belong to both atoms. Okay, so these atoms right here are sharing these two electrons. That means these two electrons belong to this one, but they also belong to this one because they're sharing. So if you look, this atom now has 1, 2, 3, 4, 5, 6, 7, 8, which is a full octet. But this atom also has 1, 2, 3, 4, 5, 6, 7, 8, 4 full octet. Okay, so those shared electrons belong to both atoms, and that's referred to as a covalent bond when they share. A molecule is a group of atoms joined by covalent bonds. So for example, if you have CO2, carbon and two oxygens bonded together with covalent bonds, that would be a carbon dioxide molecule. A diatomic molecule has two atoms bonded together. Now a diatomic molecule could be any two atoms. So for example, HCl. Is that two atoms? Yes, HCl. So it would be diatomic. O2. Is that two atoms? Well, we have O bonded to O, that's two. So that would be diatomic. But H2O, is that diatomic? No, because we have two H's, one O, that's three atoms. And diatomic is two atoms only, so that would not be an example of diatomic. So diatomic molecules either have two different atoms bonded together or two of the same atom bonded together. So let's look at those diatomics again. Because there are 7 elements that naturally exist as diatomics. And what that means is two bonded together. Just like we said, di means two. And it's really easy to remember because there are 7 of them. So you start at element number 7, like this is atomic number 7, it's nitrogen. And then you make a big 7. See the 7? So it's NOFClBri, but what's not in the 7? Hydrogen. Okay? And so what that means is when these elements are by themselves, they always have the 2. They're diatomic. They pair up. So the oxygen that we breathe, if I say we breathe oxygen, I'm not saying we breathe O, I'm saying we breathe O2. Because when oxygen's by itself, it's naturally going to pair up as O2. So remember, start at number 7, which is nitrogen. Make a big 7. So you have NOFClBri, and then hydrogen. Okay, and again, that just means they always have the little 2 when they're by themselves. Now, if it's bonded, it doesn't have to have the 2. So like H2O. Does O have a 2 here? No, because now it's bonded to something else. NaCl. Does Cl have the 2 here? No, because it's bonded. But when oxygen's alone, it's O2. When Cl is alone, it's Cl2. Once they bond, their subscripts change according to how they're bonding with what they're, come into contact with. It's very important for you to remember the 7 diatomics. If you want to know what's going to make you miss a whole lot of stuff second semester, it's forgetting the diatomics. Alright, so let's move on and talk about some properties. Okay, so I went ahead and put up the properties we talked about last chapter for ionic compounds so that you can see that molecular is pretty much the opposite. So if you remember ionic, molecular is the opposite. So let's look at ionic first. So we said ionic compounds have high melting points, which means molecular have low melting points. Ionic compounds are crystalline solids. Well, molecular compounds tend to be gases or liquids. Ionic compounds are made of a metal and a non-metal, which means something from the left and something from the right of the periodic table. Whereas molecular compounds are only made of nonmetals. So in this chapter, we're going to be focusing on the right of the periodic table. And hydrogen, of course. Ionic compounds are made of ionic bonds. Molecular compounds are made of covalent bonds. So in ionic compounds, they're transferring electrons. Some are losing, some are gaining. In molecular compounds, they're all sharing electrons. And then last thing is ionic compounds are good conductors when molten or aqueous, and molecular compounds are poor conductors. All right, another thing would be to go with this crystals is ionic compounds are crystals and molecular compounds are made of molecules. Or you can say ionic compounds are made of ions, molecular compounds are made of molecules. There's lots of different things. Okay, so remember on my tests, for my free response questions, I like to put charts, lists, and pictures or diagrams. So these are lists, so make sure you know them because I like to ask you that type thing. Alright, so let's look at a molecular formula real quick and then we'll be ready for section assessment. Hence the reason I decided to do this lesson as a video lesson. Pretty easy section. Alright, so a molecular formula is the chemical formula of a molecular compound. A molecular formula shows how many atoms of each element a molecule contains. So, this chapter we're going to refer to molecular formula. Last chapter we referred to formula unit. Okay, so let's discuss the difference in those. A formula unit is used for ionic compounds, and it just shows us the lowest whole number ratio of ions. So for example, formula unit for salt is NaCl. Now, that doesn't mean that every piece of salt is one Na and one Cl. It just means for every Na, you have one Cl. So the salt crystal can go on forever, but you have to have the same number of NAs as you have Cl. So it could be this large, and if you look, I have 1, 2, 3, 4, 5, 6 NAs, 1, 2, 3, 4, 5, 6 Cls. So that's possible. However, I could extend it. Make it a little bit bigger. Okay? This is still NaCl, but now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Cls and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 NAs. Okay, so it doesn't matter the size of the crystal, it's still going to have one Na for every one Cl. It's just a ratio. It's not telling me exactly how many I'm going to have. Whereas a molecular formula, on the other hand, shows me the actual number. So water, H2O. That means that water is literally made of molecules that contain one oxygen and two hydrogens. So H2O. All right, it's not like you're going to have an H4O2 in there somewhere or an H6O3 or anything like that. That is the actual number of atoms in each molecule. Okay, so that's the difference. In formula units, a ratio, whereas molecular formula tells us the exact number. All right, so let's look at that section assessment. So how are the melting points and boiling points of molecular compounds usually different from those of ionic? Remember, ionic have high, molecular have low. So we can say molecular are lower. Ionic are high and molecular are low, so when we're comparing the molecular compounds, we have the lower melting point and boiling point. What information does the molecular formula provide? Well, we just said it shows you the actual number and types of elements. The actual number and types of elements. And like I said, an example would be like H2O. 2 hydrogens, 1 oxygen in every water molecule. Alright, number 3, what are the only elements that exist in nature as uncombined atoms? So think about it. The periodic table. Think about octet rule. What are the only atoms that are uninterested in bonding? The ones that are already full. Who's already full? The noble gases. Now remember, noble gases, which we learned in chapter 6, are in group 18. The last column on the periodic table. Alright, so noble gases, and they're already full, so they're uninterested in bonding. The term used to describe those, some people have heard of it before, some people haven't, is inert. Inert means unreactive. And so sometimes they're called noble gases, sometimes they're called inert gases because they don't want to react. They're already full, they already have an octet. Alright, number 4, super easy. Describe how the molecule whose formula is NO is different from one whose formula is N2O. Well, what's the difference? This one only has 1 nitrogen. And this one has how many? 2 nitrogens. Okay, so the second one has an extra nitrogen. All right, so, I mean, that question was like too easy to even be on here. All right, so let's look at our last question. And that is, give an example of a diatomic molecule found in Earth's atmosphere. Okay, remember, we learned about the 7 diatomic elements. Remember, start at number 7, N, make a big 7, NOSClBri, and you have to remember hydrogen. So what would be found in Earth's atmosphere? Well, lots of people give me the answer O2 for oxygen. Obviously, that's in our atmosphere. That's what we breathe in. But what's even more prominent in our atmosphere than oxygen? Nitrogen, which of course is N2. Okay, you can give me lots of other examples, okay, but those are the 2 most common I get in class all the time. All right, so we're going to start learning Lewis dot structure next. That is not very easy for some of you, so clearly there will not be a video lesson on it. I'll teach that to you in class.